Hi everybody, I hope you guys are all doing well. I'm excited that I can do a video and we can go over some stuff that I think that you may need a little bit of help on. So I am going over the worksheet that was assigned on block day. It said chapter 10 activity. I'm going to go over some choice problems that I think you may need a little bit of assistance on. So I've chosen some of those problems. And I'm going to start with number 2, if it can zoom in for me, 2A. Actually, I'm going to do 2A and B. So I am going to give you a second to make sure you pull out this worksheet, the work that you did for it that was due on block day. Obviously, we're not in class, so I haven't been able to get a gauge about how you guys are doing. So this is really for you to make sure that you are understanding the content and getting the correct answers. So that's number 2. It says sketch the graphs. So the reason that this one may have been a little bit hard is because these two problems, you're graphing different things. Letter A, that's a circle. And letter B is a parabola. You can tell the difference because this one has x something squared and plus a y something squared. This one only has the x something squared, so you know it's a parabola. So let's go ahead and graph the circle to start. The first thing for a circle, you need to find the center. The center here is 2, -3. So I'm going to go over 2, down 3. There's your center. The radius, if that's 4, the radius is 2. So from that point, you're going to go up 2, over 2, down 2, over 2. And that's your circle. Okay? Now the parabola has a vertex. So in this case, the vertex is 3, -2. 1, 2, 3, 1, 2. And then for a parabola, you need to find 2 other points. As a reminder, a parabola, you have to have 3 points to graph it. So I'm going to go ahead and find the y-intercept by plugging in 0. Okay, so y is 34, which means my y-intercept is 0, 34. Now, obviously that point is like way high up, so that doesn't go on my graph, but this told me that I knew what I was doing, like I found something else. So I'm just I'm going to just put a point like up there, and then I'm going to put the reflection of that point. So that's what that graph would look like, kind of. Now, obviously, it's not exact. Since it does say sketch, it doesn't need to be exact. I just need to see that you guys are understanding where the points are coming from. So that was number 2. Number 3. So there's a lot going on number 3. It also printed kind of weird. I don't know if it looked like that for you guys, but it has all these like weird things. Now, it was supposed to say the measure of... Let me just double check what it's supposed to say the measure of angle BPC, the measure of angle A. So these are supposed to be angles, and it looks kind of weird. So that should be like that. Okay. So the thing that we're given that this arc BC is 32 and this arc BA is 76. The center is P. That is very important to note that that's the center. I highly suggest you have different colors when you're doing these problems because then you can see what's going on easier. So the first thing we're looking at is BPC, that angle. So that's a central angle. We know it's central because it hits the center point, and then it's intercepting that arc. When a central angle is intercepting an arc, it is the degree of that arc. So angle BPC is 32 degrees as well because it's intercepting that arc. Okay? Now, angle A is right there. That's an inscribed angle. It's inscribed because it goes from an outside to an outside to an outside. That's called inscribed. It does not hit the center. When it's inscribed, that angle is half the arc that it is intersecting. Okay, so when you take that angle, you're going to do 32 divided by 2, and that's going to be 16. Okay, because it's half the intercept arc. I was just double checking that on my notes. And then the last piece it wants the measure of the arc ABC. Now, the arc ADC, it goes all the way around that outside. Now I have that this arc is 76 and this arc is 32, and the full circle is 360. So what you're going to do is you'll do 360 minus 32 minus 76, and you get that piece of the arc is 252. So this is 252. Okay. Now, number 4, I'm only going to go over the rewriting into graphing form part because the other part's just sketching, which I already did one of those on number 2. So we are going to rewrite that into graphing form. So to do that, the first thing I'm going to do is I'm going to put my x's with my x's, my y's with my y's, and isolate the variables. So subtract that 6, and we get x squared minus 2x plus y squared plus 6y equals negative 6. Complete the square twice. So that'll be negative 1x, negative 1x. So that's plus 9. That gets added over there. I like to circle those numbers so that I remember to put them over there. So then I have x minus 1 squared plus y plus 3 squared equals, we have 10 minus 6 is 4. So that would give me a center at 1 comma negative 3 and a radius of 2. And that's what you'd be graphing on that graph. All right, so that was numbers 2, 3, and 4. Now I'm going to go over 5. Now quickly on 5A, my suggestion would be to change all of those signs. So make it a positive, negative, negative. You can do that as long as you change them all, okay? And then you just factor it from there. But on 2B, there are 2 different ways you can solve this. The first way is you can multiply that out, the x minus 4 squared. You would have to write x minus 4 twice. Or you can kind of treat the x minus 4 as a y. So let's pretend that this actually says 2y squared equals 18. Let's just pretend that it says that. Well, if it said that, you would just want to divide by 2 to start. So that's what I'm going to do over here, is I'm just going to divide by 2, which that would make that go away. Then I'm just left with x minus 4 squared equals 18 divided by 2 is 9. So you can just pretend that that just says y, so you can get rid of that 2. From there, you'll square root both sides to get rid of that squared. And we have x minus 4 equals, this is the part that kids are going to get wrong, the square root of 9. You know the square root of 9 is 3. But that's not all the square root of 9 is. Remember, it is plus or minus 3. From there, you add 4. So we have x equals 4 plus or minus 3. X equals 4 plus 3. X equals 4 minus 3, which means x equals 7. And x equals 1. You will have 2 answers. If you plug them both in, they are both going to make that correct. All right. Each part of this problem. These problems are essentially what Chapter 7 is about. The back half, we did circles, we did the equation of a circle, we did graphing the circle, we did changing to standard graphing to standard. These problems are the problems about inscribed angles, chords, central angles. So this is a really important piece of this unit, okay? All right, so we have C is the center, and then we have a 47-degree angle. Now this center is going to a line that's tangent. Now when you have a line that's tangent, that's a 90-degree angle. So we have a 90 and then a 47 and an X. We know that they're going to be 180 because it makes a triangle. So it'll be 180 equals 90 plus 47 plus X. And then you just solve for X from there. I'm not going to go over that solving. I'm just going to set it up. That's how you would set that one up. Letter B, there's a lot going on in this problem. Again, I highly suggest you have different colors of pens so you can highlight and mark up what's going on. Okay. The piece of information that you're given is this 39. So I definitely want to pay attention to that. So I am going to outline where that 39 is. That 39-degree angle is made by those two segments. Now, looking just at that, like just at that piece, that is an inscribed angle. Knowing that that's an inscribed angle, it is intercepting that arc right there. So if it's intercepting that arc must be 39 times 2, which is 78. Okay, that's the definition. Inscribed angle, you multiply it by 2 to get that intercepted arc. So from there, now I'm just going to ignore everything else. From there, I'm also looking at, well, I have this right here. That's also intercepting that arc. Now it's also intercepting that arc, and that's a central angle. That must be 78 degrees because it's a central angle intercepting that 78 degrees, so it has to be 78. And then from there, those two angles, the X and the 78, are vertical, which means they're congruent. So that X has to be 78 degrees. There is a lot of problem solving going on in these problems. You have to kind of follow the bouncing ball and see what you know about the problem and then go on to solve it from there. Okay, letter C. We have this inscribed angle intercepting that arc. So all you're going to do is double it. So you'll do 67 times 2, which will be 134. And then letter D, we have this 74-degree angle intercepting that arc, which means that would be 74 degrees. And then we have this inscribed angle intercepting that same arc. So if you think about it, what are you going to do with that arc? You're going to divide it by 2. So you'll do 74 divided by 2. Oops. And you'll get 37. Okay, because it's in the arc and it's inscribed, so you have to divide it by 2. Okay. On to number 9. Now, number 9 is actually a review problem. This was from the unit before we left school, but I did want to go over it. Okay, so John learned that the equation h equals 50t minus 5t squared. H is the height, t is time, can be used to determine the height of a ball after it was thrown. Now, I always draw a picture. So I have this, there's a ball being thrown, like that, okay? How long does it take for the ball to hit the ground? So that means I'm looking for this point and this point. Well, those 2 points are where y equals 0. So I'm going to plug that in. Oh, y is h. You can use that. X is t. It doesn't matter. So it'll be 0 equals 50. I'm just going to use x's because t's are more complicated to look at. And it means the same thing. Now to solve that, I need to pull out the GCF. The GCF, I'm going to use negative 5x. You could use 5, the positive. However, it's easier if you use a negative. So if I pull out a negative 5, I'm going to be left with x minus 10. Now you'll notice that the order changed. The order doesn't matter there. You could have written negative 10 plus x. That's perfectly fine. You'll get the same answer. Those two are your factors. So we have negative 5x equals 0. X minus 10 equals 0, which means x equals 0 and x equals 10. Okay. Find the maximum of the height of the ball. The maximum is right here. Now, if this is 0 and this is 10, the maximum is going to be halfway. So that maximum would be when x equals 5. That's what we have to plug in to find that. So we'll have y equals 50 times 5 minus 5 times 5 squared. Now I'm going to put that in my calculator. So that'll be 50 times 5 minus 5 times 5 squared, 125. And then the last part, it says, when was the ball exactly 80 feet off the ground? So off the ground is somewhere here. That's y equals 80. So we're looking for this point and this point. So we're going to be plugging in y equals 80. That'll be 80 equals 50t, or x, sorry, I'm using x's, minus 5x squared. And again, you could have used t's, that's fine. Now to solve that, I'm going to move all of this over. So that'll be 5x squared minus 50x plus 80 equals 0. I moved that side over so that my x squared is positive. Now my GCF here is 5, so I'm going to pull it out. And then you factor that. So x minus 8 equals 0, x minus 2 equals 0. You don't need to write that 5. That's your since it doesn't have an x connected to it. You don't really need to worry about it when you're solving for zero product property. So x equals 8 and x equals 2. So that means at 2 seconds and at 8 seconds, it's 80 feet off the ground. Okay, so let me switch over my cameras. So those were all the problems that I wanted to do to make sure that you guys were understanding that content. If there are other problems that you would like me to do, please let me know via email or set up a time to come in for tutoring online, whatever that looks like, so that I make sure you guys are learning the curriculum. As a reminder, I do have office hours. You can sign up on the Google Sheet, or on Wednesday and Thursday nights. I will have office hours both of those days. Friday, you guys can schedule office hours with me at any time. Hopefully you're staying at home, so you have nothing else to do except for get help. If you do need help, please get it. Let me know, email me, whatever that looks like. I hope you guys are staying inside. I hope you're staying healthy. And yeah, let me know if you guys need any more help, okay? All right, have a great day.